So let's talk a little bit about 8.2. This is this is kind of a short section. It's not really a lot I'm going to have you do here, but I'm going to put some problems that require Venn diagrams. So they're going to tell you something about some people that were surveyed, and they're going to typically have a couple of sets involved. So in number one, it says you're collecting data on 100 households. So the whole universe itself has to have 100 people total. 81 of those people have a cable TV. We'll let C be the set of people that have cable TV, essentially the whole set. We'll say I is a set of those people that have a high-speed internet. 56 have both cable and internet. It's their intersection. So when you do something like this, you start from the middle. Start from the intersection. So you would say 56 have both. That is their intersection. So 65 people have high-speed internet, which means this entire circle is high-speed internet. If this has to add up to 65, and this is already 56, we take 65 minus 56, and that has to be 9. In this circle, that's the number of people that have cable. Well, 81 total people have cable. 56 of them belong in this part of the circle. So 81 minus 56 gives us the 25 that are here. So if we take 25 plus 56 plus 9, you get 90 people total that belong in these two sets, in their union. It's the union of those two sets. Okay? So I guess if I may here, I should have done it sooner. When you talk about two sets, when they overlap, that is their intersection, the middle. So that's why we put the 56 right there, where we did. If you take the two circles together, what's in one or the other, or both? That is the union. So the union represents what's in both circles together, total. Intersection is what's in between, what's overlapping. So intersection, union is what's in one or the other or both. It's the intersection plus what's in one or the other by themselves. Okay? So these are the people that have only cable, no internet. These are the people that have internet but no cable. These are the people that have both. That is 90 people total. In this box, there has to be 100 people. So we take 100 minus the 90, and that's what's outside the box. This would be the complement of the union. So the question asks, how many only have cable TV? The ones that only have cable, this one. Because this one has cable and internet. So the ones that have cable are the 25. The only ones that have internet are the 9. How many have neither cable TV nor internet? So this is cable or internet or union. So neither nor is the outside, the complement. So 10. Outside the circles, inside the box. And that is how you essentially do Venn diagrams with two sets. And that's really what it's asking, just to kind of break everything down. Now, a 3-element set, things get a little bit more interesting here. I'm not gonna do too many of these, or I'm not gonna expect for you to do a lot for me either. But to kind of set it up, here's a problem that says 125 patients were diagnosed. So in this box, 125 people total live in there. 75 had a fever, reported a fever. So we call that the set F. So in this entire circle, 75 people have to live. 72 reported chills. In this whole circle, 72 total people. 67 reported a headache, this entire circle. 55 reported both a fever and chills. So 55 is the intersection of F and C right here. Set 47 reported a fever and a headache. It's where the F set intersects the H set. And then 49 people reported chills and a headache, this part. 35 reported all three. This is the intersection of all three sets. That's where you're going to begin, smack in the middle. So start it at the inside of all three, then work your way back. So if 49 people had chills and headaches, these two things here have to add up to the number. This is the number of people that have fever and chills and headaches. So 49 people total have to live here. So if 35 are already here, we take 49 minus 35. That means 14 live in this little piece. And you work your way back. 47 had a fever and a headache. Fever and a headache. 47 overlap. 35 are here, so 47 minus 35 makes this little piece 12. 55 reported a fever and chills. That's this total here. Well, because there's 35 here, you do 55 minus 35, you get 20. So you have this interior part already done. Then you work your way out and say, look, 67 reported a headache. That means that 67 total people live in the circle. Well, if I have 12 plus 35 plus 14, that's 61 people. This whole thing has to have 67, so 67 minus the difference is 61. So in here, chills, 72 had chills. Well, 20 plus 35 plus 14, that's 69 people. Here. 72 minus 69 leaves just 3 people left in this little part. These are people that have just chills only. These are people that have headaches only. These are the people that have fever and headache only. These are the people that have chills and headache only. These are the people that have fever and chills only. These are the people that have all three symptoms. And the last one is a fever. This circle adds up to 74. I already know the other three pieces of the 4. So 12 plus 20 plus 35. That's 67. So 74 minus 67, you have 7 here. So adding up everybody in all the circles, did that over here. That's 97 people total in the union of all these three circles. There's 125 people total. So 125 minus a 97, there's 28 people in the box that are not in the circles. So the question asks, how many had only fever? These are the ones that had only fever, 7. How many had only chills? These are the people that had only chills. How many people had only headaches? These are the people that had only headaches. And how many people had neither of the symptoms? That's this little region. So Venn diagrams help you set up little application problems with sets. And you kind of put numbers in there so you can kind of see. So Venn diagrams have an important role in sets. Okay, so that's just a small sample of the Venn diagrams that I wanted you to be aware of. And so now I want to talk to you a little bit about 8.3 and 8.4. Kind of switches gears a little bit. It talks a little bit about sets, but it's mostly about essentially probability, which is the chances of something happening. If you have an experiment, it's typically an experiment is kind of like they call it a random phenomenon, but experiment is something you try and you record results and it has outcomes, what are called possible results. And there's a regular distribution in a large number of repetitions. So it's like you might be doing something over and over again to see if this is actually true or if you feel like it's true. So sample space is a set of all the possible outcomes of an experiment. It's a set of the things that happen. So real simple experiments, like if you flip a coin, the sample space is heads and tails. So if you want, heads would be H, tails would be T. Now, for simplicity, instead of having to write tails, heads all the time, we could just put H and T. So if it's a fair coin, there's essentially a 1/2 chance that when you flip it, you're gonna get a heads, half a chance you're gonna get tails. Tossing a die. Now, a die is hopefully you're familiar with. This kind of comes into gambling here. But a die typically has values on the sides. So usually they have 6-sided figure where they have the numbers 1, 2, 3, 4, 5, and 6. So the experiment would be tossing a die once. In the sample space, you can get a 1, a 2, a 3, a 4, a 5, or a 6. An event would be essentially the subset of a sample space. An event, you might have Let's see. An experiment, if you toss it once, an event might be the event of only getting a number 2, the event of getting a 5, the event of getting an even number. When you flip a coin, you get a heads or tails. Now, an event could be getting heads when you flip a coin. So the event heads would be a subset of the sample space. So heads is a subset of heads, comma, tails. Sample space is 1 through 6. So if you toss a die, an event could be maybe I'm going to get an even number. Well, 2, 4, and 6. The event that I get an even number when I toss it once. Or the event that you get a number greater than 5, a number less than 2, those kind of things. So an event is a subset of the sample space. Sorry, event is a subset of the sample space. Okay? So suppose you toss a coin twice. That's your experiment. Now you can get H for heads or T for tails. So the sample space, you're either going to get heads, 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 tails, tails, heads, or tails, tails. Those are the only 4 outcomes you can get if you toss a coin twice and record the results. So find the event of getting at most 1 head. Well, in this sample space, the event of getting 1 head and subset of this, so you look at where there's no heads or there's 1 head. So no heads, you have 2 tails, or 1 head would be 1 head, HT and TH, heads, tails, tails, heads. So this is where you're going to get 2 heads, so you exclude that. And so the event of getting at most 1 head is just these 3 elements. So subset. Find the event of getting exactly 2 heads. There's only one way you can get 2 heads. HH. Find the event of getting no heads. Well, the only way that can happen is if you get both tails. That'll be the only way you can get no heads. So suppose a family is trying to have children. What would be the sample space? Again, assuming that there is either boy or girl. So it could be boy, 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 girl, boy, girl, boy, girl, boy, 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 girl, 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 boy, girl, boy, girl, 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 girl. That's the sample space of the experiment. What is the event of having at most what is the event of at most 1 boy? So here you look at all the cases where there's at most 1 boy. No boys or 1 boy. So no boys or 1 boy. Those are the only 4 cases. So 4 out of the 8 cases are at most 1 boy. What about exactly 2 boys? Well, boy, boy, girl, boy, girl, boy, girl, boy, boy. There's only 3 ways that you can get exactly 2 boys. So 3 choices. And then what's the event of having no girls? The only way is if you get all 3 boys. And so events are subsets of sample space. Sample space comes from an experiment you run. Okay, so an event is a subset of a sample space. An event are the smaller things that happen in the big experiment that involve a sample space. Continuing on, we talk about probability now. Now, I don't know if you're familiar, but probabilities are the chances that something's going to happen. So the probability of an event, E, happening, is the number of ways that E can happen, divided by the number of elements that are in the sample space. So the number of ways a sample space can occur, or the number of ways an event can occur. So the probability is the cardinality of the set E divided by the cardinality of the set of the sample space. So a coin is flipped 3 times. Find the following. Sample space. Well, heads, 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 tails, heads, tails, heads, tails, heads, heads, tails, tails, head, tails, heads, tails, heads, tails, tails, or tails, tails, tails. The number of different outcomes is 8. Suppose you want the probability of having no heads. Well, the probability of no heads is that they're all tails. There's only one event that's going to happen. So the number of ways that can happen is 1. The total number of outcomes is 8. So the probability of no heads is 1 out of 8. At most 1 tail. Either no tails, or exactly 1 tail. So there's 4 outcomes, 4 ways that can happen. So 4 out of 8, which reduces or simplifies to 1/2. The probability of no more than 2 heads. So it's like 0 heads, 1 head, 2 heads. So at most 2. So they all have at least 2 heads or less. no heads, one head, one head, one head, two heads, two heads, two heads. So these are at most two heads. So there's 7 ways that can happen. So 7 out of 8. Or you can say, look, there's only one out of the 8 cases that you cannot have it. So the other 7 means you have to have it. So you can say the complement. You could say 1 minus 8 out of 8 minus 1 out of 8. That'll give you 7 out of 8. There's many ways of looking at this. The probability of exactly 1 heads. So you flip it and you get 1 head. 1 heads. So exactly 1 heads, you look at the ones that have exactly 1 H in it. This one, and this one. There are 3 ways that can happen. So 3 8s. There's your event. 3. The cardinality of the set is 3. The cardinality of the sample space is 8. So 3 choices out of 8 choices. The probability of getting either heads or tails at least once. So every time you do it, what's the probability of getting at least one heads or one tails at least? Well, that's all there is to choose from, heads or tails. So they're all of them are going to be at least one tails or one heads. So 8 out of 8. So this idea, even though it's kind of redundant, it's a sure thing. Because yeah, you're going to get at least one heads or one tails every time you flip 3 coins, for sure. At least one or the other. So since, and then kind of going a little further with this, more theory here. Since an event is a subset of the sample space, it always will occur that the probability of any event is going to be less than or equal to the probability of the sample space. Because the sample space is going to be 8 out of 8 no matter what. It's going to be a full 1. So the probability, that's what it's saying, is always going to be less than 1. Less than or equal to 1. But the probability can never be negative because you can never have negative choices. So it follows that any event, its probability will always be greater than or equal to 0 or less than or equal to 1. It will always be less than or equal to 1 and non-negative. So let S be the sample space 1, 2, 3, 4, 5, and 6. Let E be the event 1 or 2, 1 and 2. So find the probability of this event E happening. Well, 2 choices out of 6 choices, so 1/3 chance that'll happen. Let E be the set 2, 4, and 6. The probability of this event will be 3 out of 6 choices, 1/2. Let E be the whole thing 1, 2, 3, 4, 5, 6. Well, the probability of E is 6 over 6 or 1. It means it's a sure thing. You're gonna if you toss a die, you're gonna get either 1, 2, 3, 4, 5, or 6 for sure. What's the probability of getting a 7? Well, if your only choices go from 1 to 6, there's no way that you're ever gonna get a 7. So the probability of this happening is 0, which means that's an impossible event. If the probability of an event is 0, there's no chance that'll happen. So we call it an impossible event. So there's an impossible event if the probability is 0, means it'll never happen, or a sure thing means it'll always happen. Because 7 is not an element of the sample space. There's no chance to get a 7. Okay, so I'll throw some vocabulary here. Then you have essentially the complement rule. The complement rule says the probability of the complement is always the 100% or the 1 minus the probability of E happening. So this is the opposite of this. So the total minus the probability that an event happens is the probability that the event doesn't happen. If that makes any sense. Suppose you select a card from a deck of cards. Determine the following probability. So here's some problems here. But before we get to that, I'm going to just explain to you how a deck of cards looks like. I don't have one handy where I can kind of show you the cards here, but if I did, I would show you that there are 4 suits: spades, clover, diamond, and hearts. Now, each of these suits, there's like the diamond, the spade here. There is an ace of spades, a 2 of spades, a 3 of spades, a 4 of spades, a 5 of spades, all the way to jack, queen, and king. So there's 13 cards that have a spade on it. An ace, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, a jack, a queen, a king. Those 13 have spades. So there's 13 spades. There are 13 clovers, there are 13 diamonds, and there are 13 hearts. So there's 4 suits 13 of each suit. Jack, queen, and king are called face cards. So there's a jack of spades, a jack of clovers, a jack of diamonds, and a jack of hearts. There is a queen of spades, a queen of clovers, a queen of diamonds, and a queen of hearts. And there's a king of spades, a king of clovers, a king of diamonds, and a king of hearts. So there essentially are 12 face cards. They're called face cards. There's 4 of each. So there are 12 face cards. There are 13 of each suit. Like I said, 13 spades, 13 clovers, 13 diamonds, 13 hearts. Just a little kind of, if you have a deck of cards, you might want to take one out and you can kind of see what I'm talking about. But nonetheless, if you select one card from a deck of cards, you want to know what's the probability of getting a queen. Well, there is a queen of spades, a queen of clovers, a queen of diamonds, and a queen of hearts. There are 4 queens in the deck. There are 52 cards in the deck, so 4 out of 52. When you reduce it or simplify, you get 1 out of 13. There's a 1 out of 13 chance you get a queen when you pick a card. Probability of choosing a 5. Well, like the same reason as a queen, there's 4 5s in the deck. So 4 out of 52 or 1 out of 13. Probability of getting a face card. It's a number of ways you can get a face card. Well, there are 12 face cards that you could pick from. There are 52 total cards. Again, this is a sample space. This is the event. So 12 out of 52, which is 4 out of 13. The probability of picking a diamond. Well, there are 13 diamonds. In fact, there are 13 of each suit. There are 13 diamonds. So you can say, look, out of the 52 cards, 39 are not diamonds. So 52 minus 39 would be 13. You could think of the complement like that. Or you can just say 13 out of 52 here, which is a 4th. So what's the probability of getting a spade or a 6? Well, in the deck of cards, there are 4 6s. 6 of spade, 6 of clover, a 6 of diamond, and a 6 of hearts. So or means one or the other or both. So there are 4 6s, 4 out of 52. There are 13 spades. Sorry there. There are 13 spades, not 12. Wait, I don't want to put 12. There are 13 spades. So this is a little off here. So there are 13 spades. There are 4 6s. However, one of those spades is a 6. So you included the 4 6s here. One of those is a spade. You include the spade, the 6 of spades as one of these spades. You included the 6 of spades as one of these guys. So there's a repeat there. So you have to subtract off what repeats, what intersects. So you don't want the repeats. So one card that has both a 6 and a spade on it, 6 of spades. So this is 13 over 52 plus 4 over 52 is 17 over 52. Minus 1 over 52 is 16 over 52. Now they essentially have a 4 in common. So you get 4 over 13. Which is the same probability of getting a face card. People take this kind of stuff and they do text, when they do hold them, what a chance of getting a pair, what a chance of getting 2 cards from a deck. It gets more complicated than this. But what about a face card or a heart? Well, there are 12 face cards. Yes. And there are 13 hearts. So 12 out of 52 plus 13 out of 52. However, out of these 12 face cards, 3 of them are hearts. Jack of heart, Jack of queen. So the face card you already included in this count, but you also included the red, the heart, the face card that have hearts on them out of as this 13 out of 52. But the 3 that overlap, you have to include that and take it out. So 12 plus 13 is 25, minus 3 is 22. So these guys share 2 in common, so you get 11 out of 26. That's the union, one or the other, minus whatever is overlapped. Probability of getting 9 and a red card. There are 2 types of red cards. So there's 26 of these red cards. However, you want and. So you want a card that has a 9 and a red card, like 9 and red. There's only 2 red cards that are 9s. There's only 2 9s that are red cards, excuse me. Out of the 4 9s, you have a red diamond 9, and a red heart 9. There's only 2 in the deck that are 9 red. So 2 out of 52, which reduces to 1 out of 56. Only the 9 of diamonds and the 9 of hearts. Essentially, that's how we look at it. Now, if you look at the probability of not getting a 5, well, in letter B, the probability of getting a 5 was 4 out of 52. So there were 4 5s in the deck. Well, that means the rest of them are not 4s. So 52 minus 4 is 48. So you get the 1 whole minus 4 out of 52. But the whole deck 1 is 52 out of 52. So 52 minus 4, 52 total cards, 4 of them are 5s. So if you take that out of the deck, then 48 of them are the complement. So I just want to kind of reiterate this. So the whole minus the ones that are the ones that are not. So the probability of not getting a face card, complement, or if you want to write out in words, the probability of not getting a face card. Well, if there are 13 face cards, 12 face cards, and there's 52 total cards in the deck, 52 minus 12 means 40 of them are not face cards. So it's the 1 whole minus 12 out of 52. But this one I'm going to put as a fraction to match this one on the bottom. So 52 out of 52, the whole deck, minus 16 out of 52, you get 40 out, minus 12 out of 52, you get 40 out of 52, which reduces because they have a 4 in common, so it's 10 out of 13. What's the probability of not getting a diamond? Well, out of the 52 cards, if 13 are diamonds, that means a difference, or 39 out of 52 are not. So 3/4. The other 3/4 of the deck is not a diamond. So that's the idea here. Then you go to what are called odds. Odds of something happening are very similar to probability, but they're a little bit different. So the odds in favor of an event E is the probability that E can happen, divided by the probability that it won't happen. Or also, how many favorable ways can you get the event to occur, divided by how many ways you can get the event to occur. So, if I may here, and I'll put it back. Notice how the probability of getting a 5. There are 4 5s in the deck. Yes? So that means that this one, there are 48 cards that are not 5s. So 4 out of 48 would be the odds. 4 in 48. Okay, let me show you what I mean here. Suppose a die is tossed once. You get 1, 2, 3, 4, 5, or 6. So what are the odds in favor of getting a 2? The odds in favor of getting a 2, well, there's only one way you can get a 2, so 1 out of 6. Which means there are 5 ways you can't get a 2, 5 out of 6. So if you multiply, again, when you divide by a fraction, you multiply by the reciprocal. Notice how the 6's cancel. So what it ends up being is, how many ways are there to get a 2? 1 way. How many ways are there not to get a 2? 5 ways. So the odds in favor of getting a 2 are 1 in 5. Or 1 to 5. So another way we can say this is either 1 over 5 or 1 to 5. Or we can actually say 1 to 5. So you have your odds are 1 to 5. Now, if we talk about the odds against you getting a 2, it's the reverse. It's 5 to 1 against you. So you have 1 chance versus 5 chances against you. So not very good odds in your favor. The odds in favor of an even number. Well, there are 3 even numbers, and there are 3 that are not even numbers. The even numbers are 2, 4, and 6. The ones that are not even are 1, 3, and 5. So 3 to 3. You have a 1 to 1 chance. So for every chance for you, there's a chance against you. So it's kind of like a 50-50 shot. 1 to 1. Means that for every chance you have in your favor, you have a chance against you. That's what it is. So it's the number of ways in your favor versus the number of ways against you. That's the odds in favor. Now the odds against you, which I'll turn the page in a second, are the ways against you divided by the ways for you, the reciprocal. So it's not. It's kind of like a probability. It includes probability, but it's not. There's a connection, but it's not really probability. So odds, like I mentioned here, as a colon, or you can actually say A to B, or divide them. So suppose there's a 20% chance of rain tomorrow. What are the odds in favor of rain? Well, 20% is essentially 20 out of 100. So that's reduced to 1 out of 5. So that means for every chance in your favor, there are 5 total chances. So 1 chance is in your favor, the other chances, the rest of them are against you. So out of the 5 is all the chances, the whole sample space. So 5 minus 1 is equal to 4. This is how many chances are against you. So if you give you probability, the number of chances in your favor are the top number. The number of chances against you are the bottom number minus the top number. So 1 out of 4. So you have a 1 to 4 chance it's going to rain. Now, against is kind of like the inverse of in favor. So against rain are the number of ways against raining divided by the number of ways it could rain. So it's essentially the reciprocal of the favor. So odds in favor and odds against are two things that are reciprocals of each other. So if you talk about odds in favor, it's a number of ways in your favor divided by the number of ways against you. Odds against you are the number of ways against you divided by the number of ways for you. So it's the reciprocal of the favored odds. So if you had a 1 to 4 chance that it's going to rain, then you have a 4 to 1 chance that it's not going to rain. So it's 4 to 1 against you. So 20% means essentially 4 out of 5 ways it's against you. So 80% against you is what it's saying. So there's a 4 out of 5 probability that it's not going to rain, which is 80%. So the odds against you are 4 to 1. So if you're a betting man, those are not good odds. For every chance that you have to win, there are 4 chances against you, which is not very good. Suppose odds against passing a class are 3 to 2. Again. So there are 3 ways against you for every 2 ways in your favor. What are the odds in favor of passing a class? Well, if the odds against you are 3 to 2, the odds in your favor are 2 to 3, the reverse, the reciprocal. So 3 over 2 becomes 2 over 3, or 2 to 3. What is the probability of not passing a class? Well, if the odds against you of passing a class are 3 against you, 2 for you, that means that there are 5 total chances. There are 3 ways against you. There are 2 ways for you. So there's 5 total chances. Remember, probability is part of a whole. So this means that there are 5 outcomes. So you add this. So odds of not passing a class, there are 3. What's the probability of not passing a class? Well, there's 3 ways you can't pass the class. 3 ways against you. And there are 5 total ways. So 3 out of 5 is the probability of not passing the class. The probability of actually passing the class would be 2 ways in your favor divided by the total outcome. That's the probability of passing the class. Again, complement. Because the 5 ways total, 3 against you, 2 for you. It's the difference. So this should add up to 1. And that's how you do essentially complement and odds and probability. And so that would put us through 8.3 and 8.4. So this is really going to be 8.1, the first video, and this next video that we're seeing here is essentially 8.2, 8.3, 8.4. So really this is the beginning of chapter 8. This is all the chapter 8 that we're going to be discussing this semester.